Here we're given a table showing the temperatures on the surface of each of these 6 planets. We're told that the temperature on Venus is halfway between the temperature on Earth and the temperature on Mercury. We're asked to find the temperature on Mercury. So, how do we calculate this? We know Earth is here at 20, and then we know Venus is here at 480. Venus is the halfway point. Therefore, Mercury is up here at our mystery temperature. The difference between Earth and Venus must be some value x, and since Venus is the halfway point, that value x must be the same as the difference between its temperature and the temperature on Mercury. Now it's quite easy to find this value x. Simply, we find the difference between 480 and 20. And quite simply, that is equal to 460. So therefore, x is equal to 460. Therefore, in order to find the temperature on Mercury, we add 460, which would be this x, onto 180. So 480. So these numbers are added together. 480 plus 460 is equal to, well, 400 plus 400 is equal to 800. And 80 plus 60 is equal to 140, and that gives us 940. Therefore, our answer is E. However, I should just add that there would have been a much more strategic way of answering this question. If we look at all the other answers, A, B, C, and D, we can all see that these values are less than 480. We know that the temperature on Mercury must be greater than that of 480 because we're told that Venus is the halfway point, and if Earth is on the lower side, Earth is only 20 degrees, that means that the temperature on Mercury must be the higher side of this halfway point. So therefore we could have quickly deduced out 230, 240, 250, 460, saved a lot of time and didn't even have to do a calculation. And here is the answer rationale. In the second question, we're given the same results table, and we're told a rule to change the temperature from degrees Celsius to Fahrenheit. And that rule is to multiply the degrees Celsius by 1.8 and then add 32. And we're asked how much higher is the temperature in Fahrenheit on Earth than the temperature on Mars in Fahrenheit. Now, in order to answer this question, we need to follow these 2 steps. First, we calculate the Fahrenheit temperature using the rule, and then we find the difference through subtraction. But the thing is, we don't have to follow all the rules to calculate the Fahrenheit temperature. That's because, as we see here, adding 32 is just adding a constant. So in the second step, when we subtract the 2, that 32 that was added onto the temperature of Earth and the temperature of Mars in order to calculate the Fahrenheit temperature, they'll just cancel each other out. And remember, in the UCAT, we don't have that much time. So we're going to use the calculator and multiply the temperatures in degrees C by 1.8 in both Earth and Mars, and then subtract them and not add 32 to either, just to find the difference. And this is going to save us some time. So 20 multiplied by 1.8 is equal to 36, so we can write that down here. And then for Mars, we have negative 60. So negative 60 multiplied that by 1.8 is equal to negative 108. Oh. And by finding the difference between these two, by doing that, we can just do 108 plus 36. It's the same. That's just how you find the difference. We can work out that the answer is 144. And there's the answer rationale. The third question asks us to find a rule on how to convert temperature from Fahrenheit to temperature in Celsius. So in order to do that, we need to work backwards. Now, if we were working in Celsius, to find out Fahrenheit, we first multiply by 1.8 and then add 32. And that gives us Fahrenheit. But now we need to find some sort of calculation that reverts us from this to that, i.e. leaving only the Celsius to one side. So rearrange this equation, basically. So first we subtract 32. That would give us 1.8 times the temperature in Celsius. And then divide both sides by 1.8. And that will give us Celsius. And as we can see, that corresponds to answer E. And here's the answer rationale. And in this question, we're asked to find the numerical value of the temperature in Fahrenheit that is the same as the numerical value of the temperature in Celsius. What is this temperature in Fahrenheit? So, there is some value x in Celsius that when we multiply it by 1.8 and add 32, we still get x. So this question is about rearranging the formula to find x. So we can bring x to one side. So we do that by subtracting the 32 to the right-hand side and subtracting the x to the left-hand side. And that gives us 0.8x is equal to negative 32. And therefore, in order to calculate what x is, we have to divide each side by 0.8. And we can use the calculator to help us out with that. So 32 divided by 0.8. But just remember we're working in negative, so the answer is negative 40. So negative 32 divided by 0.8 is equal to negative 40. So therefore our answer is negative 40 degrees Fahrenheit. And here again is the answer rationale.